Okay. Next is the last talk in today, given by Giuseppe Riccio, right?
Yeah, can you hear me?
Yes.
Yes.
Okay, okay.
A web application infrastructure for astronomical data analysis and instruments monitoring and diagnostics.
Okay,
Please go ahead.
yeah. My presentation is online. Yeah.
Yes. Now, yes. Only
Yes.
now.
AIDA.
Okay. Yeah. Thank you. Hello, everybody. I'm Giuseppe Riccio. I'm a member of the Astroinformatics group of the Astronomical Observatory of Capodimonte in Naples. And today I'm presenting an advanced infrastructure for data analysis for astronomical systems. We all know that today we are flooded by a huge quantity, a huge amount of data coming from ground-based and spaceborne instruments, and data are spread all over the world. And so it is very difficult to handle with such data and also to keep the quality of the observation under control, to detect the anomalies in the acquisitions. It is difficult also to correct such problems rapidly in practice to ensure the correct maintenance of all components and the good health of the scientific data. It's crucial above all for the spaceborne instruments. It's clear both in logistical and economics terms. In this context, we present AIDA, which is a modular, portable, flexible, multi-user web application. It has been designed to provide an efficient software infrastructure for the monitoring of data acquisition systems, the diagnostics, and data quality analysis, in particular for astronomical instruments. The AIDA is focused on the three main goals. AIDA is designed for the daily mission operations to monitor the status of the instruments. For the short, mid, long-term activities, to report the instrument behavior over the time by monitoring housekeeping, telemetry, and to reporting anomalies and problems. And on data analysis, providing a set of tools both for standard statistical tools and models based on machine and deep learning. AIDA must be manage the huge quantity of data coming from remote data archives, and so it is strongly based on multi-processing and multi-threading tasks, and require a high-speed network connection to retrieve such data. As every web application, it is divided into two sections. The front end, which is based on standard web technologies like HTML, CSS, PHP, and JavaScript, and the back end devoted to the data retrieval and data analysis, developed in Python. In particular, the machine learning modules are based on the scikit-learn package. And in the interface between front-end and back-end is managed by using IX technology. All the infrastructure is based on a local MySQL database, which includes a number of various kinds of information, user data, for example, documentation. In such database are stored the experiments, the plots the user want to store, and also periodic reports and on-demand reports I'll explain later, which is that the AIDA can produce to monitor all the data. it is important to stress that all the data used during the analysis downloaded from the remote data archives are only temporarily stored on the AIDA server and deleted after use, thus avoiding useless mirroring of data repositories. AIDA has four main functionalities, use cases. First, instrument monitoring, report generation and delivery. AIDA can produce some reports in which are reported the results of analysis on predefined parameters and systems. This report can be periodic, then with automatically produced with a fixed step during time, each day, each week, each month. But also such report can be produced on demand or request by the user by using the configuration files like created both or either on your machine or directly on the web application. The second functionalities is a set of visualization exploration tool. In particular, AIDA can produce plots for the selected parameters by filling some forms, histograms, scatter plots, trend analysis, and includes also an image viewer in which you can display astronomical image, select areas, do some statistics on the image, and extract the thumbnail from the image itself. As said, AIDA provides a number of statistical estimators, both standard like mean, median, standard deviation, some special estimators, for example, sigma clipping, mode, map counting, and provide also a number of models for prediction, classification, and regression experiments based on machine and deep learning. This is an example of plot generated online on the web application. The user can fill a form and select the dates for the acquisition, the parameters, and the systems to visualize. And AIDA automatically download the data and plot them. All the plots are interactive and navigable, so you can zoom, pan, select points, and all this stuff. AIDA produces also some statistics on the point downloaded, and also all plots and statistics can be flagged by a quality index and stored on local database, for example, to store a plot in which you can you find an anomaly, for example, for a parameter or an overrange. The Image Explorer in AIDA is based on the standard DS9 software, so it includes all the functionalities of the DS9. Then you can display feeds, PNG, JPEG image. You can navigate them, select specific areas, do some statistics, plot them in some specific panel. And also you can extract thumbnails. In particular, it's foreseen in the next releases of AIDA the possibility to automatically create thumbnails basing the extraction on tabular data in order to build an input data set for the deep learning models. The reports, both periodic and on-demand reports, are easily configurable. You need only to fill a JSON configuration file in which you can indicate the systems to monitor. For example, here in the online editor, it's possible to see some, for example, VIS, NISP, quick look analysis, and the parameters to monitor, and the operation to do on the data. So if you want to have a plot, to have a statistical function. The report output is composed by two files, an XML version in which all the data are reported, and a more user-friendly PDF file for, yes?
2 minutes more you have.
Yeah. Finally, AIDA includes more than 100 prediction, classification, and regression models based on machine and deep learning. You can apply them on tabular image data, for example, to find anomalies and then outliers, or correlation between the instrumental information. Even in this case, you can use them by simply filling a form, an online form. A very important feature of AIDA is its flexibility. AIDA has been designed as a modular system based on object-oriented programming. So it is easily possible to extend its functionalities, both by integrating a new system to monitor, and also by adding new functions, new statistical function, both classical and data mining and machine learning methods. It is not pluggable, but it is very easy to include a new system, a new function, because the steps to do are very few. And in fact, a specialized version of AIDA was recently appointed as instrument operation diagnostic analytics and monitoring services within the Euclid Space Mission. In conclusion, the AIDA web application has been designed to be an efficient and intuitive software infrastructure to support monitoring, diagnostics, and data quality analysis, in particular for astronomical instruments. It provides a number of tools for data analysis and system diagnostics, periodical report, visual tools for exploration, plots, image viewer, and statistical tools, both standard, classical, and machine learning, deep learning based. It is very easy to use, and being a web application, it does not require any installation on client machine. And being designed as a modular system, it is possible to integrate and customize monitoring and diagnostic system, as well as scientific data analysis solutions. Thank you.
Thank you, Giuseppe. Now the paper is open for questions, comments. Yes, Anais?
Yes, hi. I had a question a little bit, if you could expand on the machine learning models that you have. Do you have some specific targets? Are you trying to be more generalistic to find clusters of events? Can you tell me a little bit more, Giuseppe?
At the moment, the machine learning section is in progress, in the sense that we have included in practice all the scikit-learn package inside AIDA, but the idea is to enlarge with some other model from Keras, but the idea is still in progress. But then we have also some ideas, some at the moment it works on, as said, on the scikit-learn, all the scikit-learn models. So I cannot be more precise about that.
No worries. Thank you.
Thank you. Any other questions, comments? Does AIDA have a function of overlaying, say, image data taken with different instruments? Say, overlaying X-ray over optical or optical with the radio.
The image viewer is based on DS9, so you can display every kind of its file, like Aladdin. Also, Aladdin is the same has the same functionalities.
So the overlay is not difficult. Overlaying two different images on a plane.
Yeah.
Okay.
It's possible. Yeah.
Thank you. Okay. Time is over, and yeah, we had a very variety of talks in this 3 hours. Of course, it's too late in Japan, so I want to close this session. Thank you all the speaker again, and let's thank all the speaker again, and especially for time management. Thank you very much.
We could all clap, I suppose.
Okay, and we'll come back tomorrow again from the same time. We will have 3 more days in this conference. We are looking forward to seeing you again. Goodbye.
Thank you all very much.
And thank you for local organizers at the University of Tokyo for hosting.
And thank you, the chair. Great work. All the speakers, thank you.
Thank you.
So using this free time, I will show this thing with nunchaku toy because I want to illustrate a basic angular pendulum. So like a usual pendulum and rotating pendulum. And sometimes it was in chaotic regime.
Yeah, you realize that this is being recorded.
Yeah. No, it's okay.
Yeah, yes.
It's toy nunchaku, not real ones. They are soft.